Alright, we are given the derivative of a function, 2x minus a, where a is some constant. We're given the turning point, the coordinates of the turning point, and we're asked to find the equation of the original function. So just looking at the derivative, right, the gradient function, it is linear, so I would expect the original function, f of x, to be a quadratic, right, something x to the power of 2. Alright, so how can we make use of this information here? So what is the gradient at a turning point? Right, the gradient at a turning point, if you were to draw a tangent line, it would be flat, which tells us the gradient is equal to 0. So, when x is equal to 3, the gradient is 0. In other words, f prime of 3 is equal to 0. Now, why is that useful to us? Well, we know what the gradient function is. However, we don't know what a is. So we could find out what a is first before we integrate, before we anti-differentiate. So let's try that. So f prime of x equals 2x minus a. Well, we know when x is 3, the gradient is 0. So we're left with 0 equals 2 times 3 minus a. So solving for a, 0 equals 6 minus a. We'll add a to both sides. So a equals 6. Great. So therefore, the gradient function is actually, more precisely, 2x minus 6. Alright, so have we found the equation of the function? No, we found the equation of the gradient function. But that's still helpful, because when we anti-differentiate, we get, so 2x to the power of 2 divided by 2 minus 6x to the power of 1 divided by 1. Don't forget, plus c. There could be some constant, right? Because when we differentiate, the constant goes away, but when we anti-differentiate, we don't know if there's a constant or not. But more cleanly, we can write this as x squared minus 6x plus c. Alright, so we have anti-differentiated, however, we haven't found the equation of the function. Because what is c? C could be 0, it could be 1, it could be 100. We don't know. To find out what c is, we need to substitute in a point that is on the original function. So we are given a point, 3, 4, so let's substitute. So just to make it a bit more clear, I'll just rewrite this as y equals x squared minus 6x plus c. We are substituting the xy value, 3, 4. So in for y goes 4, in for x goes 3. And then we can solve for c. So 4 equals 9 minus 18 plus c. 9 minus 18 is minus 9. Add 9 to both sides, we get c equals 13. So let's put it together. So we found c. So therefore, the original function f of x is x squared minus 6x plus c, where c is 13. Awesome. So to recap that question, we were given the gradient function and some information about the turning point. So we use that information to find A, and that is actually worth achieved for this question. Secondly, we anti-differentiated. Don't forget the plus C, and that is merit. And finally, if you correctly substituted in a point and solved for C, that is where you would get excellence for this question.